Welcome to my application. It's called Airline Revenue Management Dashboard. As you can see from the navigation panel, we have all flights, we have all classes, we have a query button. When the essence of this application, it provides prediction of future revenue and also offers the demand signal. As you can see from the navigation panel, we have the flight, we have the class, we have the cabin, the actual bookings, predicted bookings, actual revenue, predicted revenue, incremental revenue, load factor, and the demand signals. So for example, if you want to calculate all the data, we query first. So all flights we query the total revenue, predicted revenue, and the incremental revenue. The incremental revenue is the difference between the predicted revenue and the actual revenue. Now, importance of this application provides real-time visibility to load factors and yields. By identifying underperforming flights early, revenue managers can trigger promotional pricing to fill seats or raise prices on high-demand routes to capture more margin. It also serves as a centralized dashboard that aggregates historical booking data and real-time demand signals. This allows airlines to move from static fare buckets to dynamic pricing, which we can increase revenue by 2 to 10%, simplifying and aligning prices with the customer willingness to pay to a specific moment. By automating data ingestion and visualization through a web-based analytics reduces manual overhead. This allows analytics to focus on strategy rather than data entry, leading to a faster response time to market disruption. By understanding the routes customer segments are more likely to purchase add-ons, helps the airline tailor its marketing and branding strategies. By analyzing revenue per available seat kilometer and cost per available seat through this app, executives can make data-backed decisions on whether to expand, maintain, or cut specific routes. So you can see these are the example of the flights, the cabin, whether it's first class, economy, or business classes. So I'll go through how this model was developed. As you can see here, we have the source data, we have the bookings cumulative CSV file, we have the fare classes, we have the fares and the flights, we have so we're using a Flask server to process the data. So this is where we load the prediction. This is the model. This is the booking for the curve endpoint, and these are the routes so that we can display on the front end. So this is our front end CSS file. This is our JavaScript file for enabling us to do the query. So this is the code for training the model. We have used the sklearn Python libraries. So this is where we imported the data source. You can see from the booking, fares, flights, and fare classes. So this is where we do the pre-processing so that we can generate the prediction files. So what else? So we have the requirements. You can see it's the Flask, Pandas, NumPy, and the prediction model. So you feel free to go through the application. It's hosted live. You can find it at the link below. Thank you.